Hi, everyone. My name is Zidit Richard, Innovation Manager at Bell Textron Canada and the Treasurer of the Montreal Ottawa VFS chapter. Thanks for joining us today for this VFS presentation of the Griffin Limited Life Extension Program. We have three very interesting presenters and even one special guest. So during the presentation, you can use the question section of this software and we will answer them at the end. But before we start, today being the first Canadian National Day for Truth and Reconciliation, I want to acknowledge that the presenters of this event and myself are in the traditional territory of the Mohawk and Algonquin nations, but more specifically, the Omami Weniniwag and the Kanyan-Kehaka people. So this is known as Mirabel, Quebec today, but it has a long history as the home of the First Nations of our continent. So now I pass the mic to Don.
Okay, so can everybody hear me? Yes, I assume.
We can.
Perfect. So thanks Edith for the opportunity for given to us to present a little bit of our project. My name is Donald Falardeau. I'm the project manager for this project at Bell. I look after pretty much all aspects of the project and is a prime interface to the project office on the government side. The next slide, please. So you saw the overview, but I'll just go through this very quickly, what we're going to do today for the hour. We're going to go over a little bit of what the Griffin is all about for those who are not familiar with what the Griffon helicopter does for the Canadian Forces. And then we'll proceed with an explanation of the project itself from a program perspective, and then go into the details of what this project is all about in terms of modifying this helicopter. Then we'll touch the three aspects that are whether were challenges on our project or things that we thought was interesting for this webinar on the certification, the digital thread, the cybersecurity requirements, which is new to a Canadian government program, and we are the first ones to actually execute those requirements. So without further ado, I'll go to the next slide right now. And before we start this talking, we have this neat video that's you can find on YouTube, and it does go over what we call one wing operation, which is the entity in the Royal Canadian Air Force that operate the Griffon helicopter. So it's just a minute and a half, and it's a lot of fun. So go ahead, Chris, if you can run the video. So that was exciting. Anyway, you can find that on the YouTube. There's other one wing videos on YouTube that are also available that you can go see. So next slide, Chris, please. Okay, so I'll talk about the Griffin and the relationship that Bell Helicopter has, not helicopter, but Bell Textron has with the Griffon helicopter. It started in the 90s when the government of Canada first acquired 100 helicopters, and we have a slide for that, and we have a really good guy to explain this since he was on the program at that time. Once the acquisition was done, that took about 4 or 5 years to do. Then we supported the helicopter through various what we call service pillars. Until in 2011, there was a contract put in place to bring all these services together, mainly for providing all the materiel, providing engineering services and maintenance services to the government. And just lately in 2019, we were given the sole source contract to update the Griffon helicopter to ensure that it can live beyond the 2030s. I'll pass it on to Andy Sayer, who will just go over a little bit of the initial procurement of the Bell helicopter by the government. Go ahead.
Thank you, Don. Do you want to go to the next slide, Chris? Okay, so we're going to talk really back in time, but I'll just say a few words about myself just to start with. I'm the on this project, I'm for Bell, the ILS manager, and I look after also certification. So I worked on this project many years ago when I was a little younger than I am today. So it goes back to basically April 1992, where there was a contract signed for this project, the Canadian Forces Utility Tactical Transport Helicopter, the CFUTTH, and it was there to replace three models that were already in service. So the Iroquois, the Twin Hui, and the Kiowa. It was initially certified by the FAA as what we call the Model 412CF, Bell calls it. But as soon as they got delivered, they were transferred to the Canadian Military Registry, and I guess they're known as the CH146, and still will be. And we'll talk a little bit about how that might change when we do the GLLE modification. There are still 83 aircraft, I would say, fully active. There are 2 that are kept on the ground as training age, but are otherwise fully configured. And 9 aircraft were actually returned to the Civil Registry as 412CFs, and they're used for training. You can see some number there for the fleet hours, etc. But I think what's of interest here is actually the first aircraft we've got for the development and in Mirabel to start working on the modification is 46467, and that happens to be the high time aircraft. So with that, I'll pass it back, I believe, to Don.
Yeah, I'll for the next slide. We want to show you what the Griffin does in the RCF, and for that we have a special guest. Very happy to introduce. So next slide, please, Chris. So very happy to introduce today Major François Roy, an engineer from the University of Chicoutimi. Joined the RCF in 2006, got his pilot wing in 2009, went to a tactical helicopter squadron and at 430 at that time, on operational tour in Afghanistan in 2010 and 11, as you can see. Then went on to be a Griffon helicopter pilot instructor, and finally ended up in its current position in the Air Requirements Office at the headquarters. And his current role in the project is very much to be our counterpart as the user representative of all the updates that are going to take place in the aircraft. His position title is the Deputy Director of the GLLE program. And so thank you very much, Major Roy, for doing this. Obviously, you're going to be the interesting one to listen to as the end customer. So over to you to present what One Wing does.
Thank you, Mr. Falardeau, and welcome everyone. Next slide, please. So it's a real pleasure for me to be here today and discuss this Griffin Limited Life Extension project, which is a very important one for the RCF and for Government of Canada. While the Griffin is the second largest fleet in the CAF, right after the CF-18 fleet by just a few aircraft short, it is certainly the fleet that is spread across the most locations in Canada, 11 of them. It is also probably the most versatile fleet used in many different roles. I'd like to go over maybe 4 of them, the 4 main roles of this fleet. So first, we have the tactical aviation, which represent 2/3 of the numbers of aircraft that we used. These aircraft are a green scheme painted as the one you see on that slide in the middle, and they are used to support the Canadian Army or our deployed humanitarian assistance force. They are located in Edmonton, Alberta, Valcartier, Quebec, Gagetown, New Brunswick, Saint-Hubert, Quebec, and Borden in Ontario. Then we have the special operation role, one unit located in Ottawa that supports the Canadian Special Operation Force Command. We, as a third role, we have the primary search and rescue. Those would be the yellow painted aircraft, like the one you see on the bottom left corner here. And those provide the search and rescue support located in Trenton, Ontario. And finally, there's the combat support roles. 3 unit cover that role. Those would be the one located in Bagotville, Quebec, Cold Lake, Alberta, and Goose Bay, Newfoundland. So to operate that fleet of 83 aircraft, roughly 2,000 RCF personnel support the fleet, and that would be about 500 aircrew, pilot, flight engineers, mission specialists, and SARTech. Next slide, please.
So to now talk about the project itself, there was 3 objectives that were provided from the Government of Canada for updating the Griffon helicopter. First was to replace all the obsolete equipment on board, and that deals with all the analog systems and all the digital systems that were on board, military and civil. The second objective is to meet all the new communication, navigation, surveillance, and air traffic management requirements. And folks, those that are on the phone, they will understand what I mean by ADS-B out, RNPR nav, so that's navigation via GPS and no longer by using ground-based radar type equipment, ILS, VOR, and such. And there's no necessarily like pure capability improvement part of the program because it's limited. However, if the capability was brought into the project as a byproduct of obsolescence replacement or integration of system, then that was allowed. Obviously, the mandate was to maximize off-the-shelf solutions. Next slide, please. Now, the project is in 2 big phases, and these phases are the Government of Canada project phases, the definition and the implementation. We are in the definition phase on the left. We are nearing completion of that phase, and on 1st of April 22, we're going to enter the second phase, which is that implementation on the right. So in that first phase is mainly the development of the solution, putting the bases in place in order to achieve a fleet retrofit. We're doing this through an existing contract, which is that in-service contract I discussed earlier. On the right side, that 6-year contract, there's a new specific to GLLE contract by the Government of Canada will be provided to us on 1st of April. The main objective: complete the design, test and eval, all the logistics supports that they need in order to operate the fleet, and then the retrofit of the fleet that we will execute via subcontractors as mandated by the contract. And that should last up until 2028. And that's pretty much it for the project. And I'll pass it on now to the interesting part, which is that technical side, which my colleague and Pierre will.
All right, thank you, Don. Before I get started, I'm Pierre Drouin. I'm on this project, on the GLLE project. I'm the systems engineering manager, so I manage the engineering portion of the project. And for your own information, I've been at Bell for almost 16 years now. So before I get into explaining what is GLLE, we need to just go back a bit and say what actually is a Griffin. So it's not a commercial aircraft. It's a military aircraft, although it's based on a commercial backbone. It's really a military aircraft. It's operated militarily with military, mindset. It has a lot of military equipment on it. And we need to go back also to what were the design objectives of the government when we started. So one of the main objective was to Don said it about navigation and stuff, but another objective was to maximize commercial off-the-shelf products, and that's to reduce the cost, reduce the certification risk and burden, and also reduce the technical risk on the project. So So what did we do? Well, if you look at the chart there, you see the 412 product evolution, and you see also at the bottom there the Griffin product evolution. So it started in the mid 90s with the 412 EP, and we took that back then and militarized it into the Griffin. So that's what you see. So you start at the left there with the Griffin EP and the not the Griffin EP, the 412 EP and the Griffin, and then both products evolved. The 412 evolved into the 412 API and then the 412 APX. We introduced stuff like fast cockpit, digital engine, and all kinds of kits and stuff. And at the same time, the Griffin evolves from the early 90s, and then we upgrade systems, we add capability, we add stuff to it, and then it becomes the aircraft that it is today. And now we need to modify that to get to the objective that Don talked about. So what did we do? So we maximize the use of the 412 product line. So we look at the EPI. There's a glass cockpit there, so we'll take that, put it in the Griffin. There's the new engine, digital engine there. That's the PT6-9. We'll take that, put it in the Griffin. At the same time, we take all those military equipment. Some of them are obsolete, so we take those, take it out, upgrade these equipments to the newer version or to a new supplier, and put that in the Griffin. So essentially, at bottom line, what you get there is you get a Griffin with a glass cockpit from the EPI, the engine from the EPI, multiple refresh upgrades of equipment, either from the EPI, some from the EPX, but also on the military side. Due to the extent of all that, we completely rewire the aircraft, and we do all kinds of airframe modifications to mostly accommodate those new systems, but also to do performance improvements there. So next slide, please. So here you see a view of the cockpit. To the left, bottom left, is what it looked like, what it looks like today. And to the right is what it's going to look like when it's out of the mod line. So you see the forward display units, MFDs and PFDs from the 412. You see the core setting selector panel also from the 412. The fuel and engine panels from the 412 directly EPI. But also what you see there is a lot of the equipment that's from the military, that's not from the 412. You see the FMCDO, the computers on the pedestal there. There's a new ESYS, new ICS. You see also the cyclic and collective grips that are upgraded. And you see all the survivability equipment or aircraft self-defense equipment panels that are there, which are strictly military. So major difference in the cockpit, how it's going to look like. Next slide. Also, I did mention the engine. So you see there at the top left, the PT60-9. So for this one, you get, of course, increased performance. It's digitally controlled, so you get better exceedance protection, more effective troubleshooting, and lower maintenance costs with this. At the top right, the LRU replacement, LRU relocation, so improved performance on all of them, most of them at least. Improved system separation. We took some decisions there to improve that, and also improve access for maintenance. In terms of airframe at the bottom left, you see an example there of the instrument panel and pedestal that we've redone completely. There's also a lot of modifications across the airframe to facilitate manufacturing, especially routing the harnesses. And that's exactly that fourth image there, which is all of this new wire that we've done, completely rewire the aircraft to also improve system separation. We use composite wires, which are lighter and smaller, and then improve maintenance and installation capabilities there. So next slide, please. So now how do we do that? We have multiple challenges. One of them was the design tools, and we'll talk about that a bit more. Military and commercial equipment integration, that's been a challenge also, and then certification and cybersecurity. Andrew's going to talk about that a bit later. So next slide, please. So on the design tool side, well, we had the first option was to go back to the early 90s and design it as it was, since all of the engineering for this machine is all in 2D prints. So some of them handwritten. So we had to think about it. So go back to the cardboard stuff. And by the way, those cardboard boxes, we still have them. So it's the original version from 2013. We have a few. See, we all have ours, and we still use them today. But it was like, imagine, designing a design team of 40 working on 2D prints. That's the way it's been done in the mid-90s, but that's not the way we work today. So we would need to get people back in time to do that. So that was not, the preferred option. So next slide, please. The other thing we looked at is something that you would see in the more modern design, which is called digital thread. All right, so you start from a 3D design product, which is at the bottom left there, and everything is tied to that. So you use that information in your part fab. You roll that into the planning with 3D planning. You have virtual reality somewhere, for the customers to see the aircraft. And it's all integrated, even from the requirements to the parametric models and all that stuff. You get a lot of benefit from that, especially the fact that you can use the engineering design information in the downstream activities. But in our case, well, we start with no 3D, no digital design, essentially. So, using this as is was not an option. But then there's a lot of good stuff in there. So how do we leverage those tools that are built and designed to work in that digital environment and use them on something that's not so digital at this point? So next slide, please. So we do something in the middle, right? So we do a hybrid option. So we use the cardboard stuff still. You see it at that picture there, but we use it in combination with 3D printed parts that were designed in 3D. We also focus on getting a 3D mockup, and it's a 3D mockup. It's not a full design, but it's a 3D mockup of the helicopter where we need it. All right, so we put out some rules of when do we incorporate a part in the 3D mockup. Those are unreleased components, so for reference only, but they allow us to visualize the concept and see stuff in 3D, so we can help the design team. And then we do the release process also in a hybrid mode, meaning when we release with 3D components in 3D digital part definition, but also in 2D. And we figure that we have about 75% of the parts in the 3D mockup. You see, at the center there, bottom, an image of the mockup as it is approximately today. And you can see how in those images we've leveraged the 3D printing capabilities and with the 3D design capabilities at the bottom right there with the harnesses. So in the end, what's the outcome of those design tools? What does it give us? So next slide, please. Back to that digital thread. So and if you go straight to the next one, Chris, please. That's the little animation. What do we get? So these little skulls, we don't get that at all. At the left, so no analytical and penetrable model inside this digital environment. We have some, but they're outside. Same for the requirements, they're outside of this environment. We do get the product design, so that's a pot of gold. Why? Because we get information that's digital, that's accessible to everyone, so that feeds the product visualization, so that allows us the design team to work in the 3D, to have design reviews in the 3D. And especially in this pandemic time, it was very, very much useful to be able to do that and to have a mock-up to be able to do that. And of course, we get other benefits that in the part fabrication. We get the detail part that we do. We design in 3D and we get the design out in 3D. So that helps us a lot speed up the stuff. And especially for the harnesses, getting that 3D mock-up done, getting the 3D routing of the harnesses in there allows us to fully leverage the Mentor Graphics tools, such that we can bridge between the wiring diagrams, the harness, and the 3D stuff. We can get those 2D form boards done within the system, getting all the harness lengths and the breakouts and that stuff at the correct locations directly out of the system, and not have to measure all these manually with ropes like they probably did in the mid-90s. So that was a significant benefit for us. So that's the design tool. So if we go to the next slide, the other challenge that we had was the integration of the military and commercial equipment. So essentially, you have a commercial aircraft, you need to put military stuff in it, and there needs to be control in there, who does what and when. So how do you do that? Well, you build a wall essentially. So you separate the aircraft in two roughly. It's a big term. It's not exactly that, but that's kind of the way I like to say it. So if you go to the next slide, there's a little animation here again. so you build a wall. So what that wall is that FMCDU component that just appeared at the bottom there. So you essentially have the commercial aircraft, which is the Airing 429, the display units, all this blue line stuff that you see in there. That's the commercial aircraft. So that's most of that stuff is coming directly from the EPI. And at the bottom there with the FMCDU, the red lines, the MIL 1553B data bus with the systems that are in orange, that's the military side of the aircraft. And what really bridges the two is the FMCDU. So the data that needs to go from the commercial side of the aircraft to the military and vice versa gets there through the FMCDU. The FMCDU controls the information, transfers the information from one side to the other. And that's where we do the customizing of that interface. So we open up that software, work that software such that we don't have to work on all these commercial item softwares. So that allows us to reduce the development cost by a lot, and also reduce the risk as we focus the software development on just a handful of units, and mainly on that FMCDU unit. So that was the method that we used for this one. So that being said, so I'll hand it over again to Andy to talk about certification and cybersecurity.
Thank you, Pierre. Always interesting to me every time you say it. Fantastic. So I'm going to just talk about a little bit of basics on certification to start with, and not everybody maybe is in the room is aware of this, but probably some of you are. So really, just very, very basic. Aeronautics Act was passed, which basically governs, aviation safety, but it governs it both for what we call military aircraft and civil aircraft. So on the civil side, that's the Minister of Transport, and then via Transport Canada and all that. But on the military side, it's the Minister of National Defense, and that gets flowed down through that organization. And just to say, really for our project, and at least what Bell is involved, we're mostly dealing with the Technical Airworthiness Authority, the TAA, the bottom right there. So you can see that you can think of the TAA as being equivalent to, say, the FAA or Transport Canada, TCCA. Want to move to the next slide, please, Chris? So this is just a quick chart here, a little small, but basically to start at the end, what we're really trying to do, when I say we, it's really the whole project, I'm not just talking about Bell here, is to achieve full operational capabilities. The top right, that last box, that's really where we're ultimately aimed. And that means that we need to have a platform or a weapon system, in fact, that's both certified, it's safe, but it's also suitable and effective. Really, again, on the Bell side, we're more focused on the safe, so what we call airworthiness clearance, and ultimately airworthiness clearance, but that comes from an airworthiness approval. So we're really working on that bottom left boxes there, the type certification. Now to get there are several steps. So obviously, get type certification, we've got to gather all the data, we've got to do the testing, gather the data, do the analysis. And so we're going to be starting off getting an experimental flight test permit from the TAA in order to conduct testing basically on the first two aircraft, what we're calling the development aircraft. That'll lead to the next big step, which is not something Bell does, but it's very important. It's called operational test and evaluation. So this is when we give, when the government or the DND take aircraft and they actually use them or test them to make sure, and that's really the suitable and effective part, right? So it is safe, it is certified, but does it do exactly what we wanted it to do? And so that's called operational test and evaluation. And then before we can put aircraft into operational units, we're going to need at least probably a what they call technical airworthiness clearance and probably a preliminary technical airworthiness clearance, and that's that box at the top. And just one last thing on this slide so people can understand, and sometimes we trip on this at Bell. You know, the airworthiness authority is the TAA. I already said that. The type certificate holder for the CH146 is actually the weapons system manager. So the group within DND that takes care of the fleet. And the applicant is not Bell. It is the what they call the program management office, the GLLE program management office in Gatineau. So they're the applicant. Bell has a contract support, basically the PMO. So we're doing really most of the work, but it's really the PMO who are making the application for approval of the GLLE modification. Can you go to the next slide, please, Chris? Thanks. Okay, so certification strategy. I'm not going to get into all the details of the certification plan, but something that you've heard it said a few times here. We're really trying to leverage off changes, systems, equipment that was already approved on the 412 commercial line, and that we show the chart there, bottom left. So this is a process within the TAA that allows us to allows the TAA to accept a previous finding of compliance, and it's called type design examination. So for those elements of the GLLE modification, such as I'll give the engine installation, some elements of the glass cockpit, but there are other elements. We can use this type design evaluation process, which basically means, first of all, showing that the previous certification was acceptable, which means the standards that we use, in this case, FARs, Federal Aviation Regulations, are suitable, and the certification authority, in this case, the FAA, is acceptable, and I think that's pretty much a given in this case. And then that the installation on our product is applicable. In other words, but both physically it's applicable, it's the same or very, very similar, but also the limitations in which it's used, the environment in which it's installed is similar. So that's called applicability. So we're going to use those two to really make sure that the certification has the least risk possible. But of course, there will be elements that are new for the Griffin that will obviously need a full certification. Can you go to the next slide, please, Chris? So challenges. Obviously, every certification project is a challenge, and I won't get into all the details of ours, but just a couple of things I would highlight here. Again, in the civil operating world, and I'll talk about the way Bell thinks. You know, we're very used to a civil operating environment. So and it doesn't change tremendously between one civil model and another. It's pretty much the same thing. In this case, we're dealing with the CH146, and the CH146 has its own operating environment. It's actually defined in a Statement of Operating Intent, SOI. Although there's a tremendous overlap, there are uniquenesses about it, and it's something that we need to understand. So when we talk about certification, we need to certify the CH146 in its operating environment, and that operating environment includes things we're not used to. So I put a couple of examples here, but it could be gunfire. You know, you saw in the video, the guns installed on this aircraft, and guess what? The gunfire creates a lot of vibration, an unusually high, different vibration, and we need to make sure the equipment on the aircraft is qualified to those levels. I won't get into all the details, but sometimes it's hard for us to get our mind around the fact that this is the operating environment we need to certify to, not the 412 EPI operating environment. And the other thing, the little orange box there is cyber. So that's another thing that's not new, particularly for civil aviation, but I'm going to tell you why it's a little bit different on our project. So can we go to the next slide, please? So when I talk about cybersecurity on the GLLE project, there's two aspects. There's something we call aircraft cybersecurity, and aircraft cybersecurity is very close, very similar to what is now happening on the civil world. Special conditions generally. I know the EASA recently came out with some rule for cybersecurity, and it's all about making sure that in the case of a cyber attack, you can continue safe flight and landing. Okay, so it's sort of akin to a system safety process. But the other area that is I would say unique to a more of a military type aircraft is cyber mission assurance. So it basically means that you have to show that not only can you continue safe flight and landing, but if you have a critical mission, you can complete that mission. So it's a little bit like saying, I'm going on holiday to Florida. There's an issue with the aircraft. I don't just have to divert and land and everybody gets off safely. I do need to get to Florida for my vacation. Okay, so I would say, you know, it's an added level of difficulty. The other thing about cyber mission insurance is a little different than aircraft cybersecurity is that, you know, you have the normal, well, I lose a function. There's a malfunction with the system, but with cyber mission assurance, we also need to protect data. So there is the idea of confidentiality. So we need to make sure that the systems and everything are, let's say, protected against cyber attack for the data within them as well. So this adds an additional layer of, would say, complexity to that. Just one more slide. Do you want to go to the next slide, please, Chris? So still on the subject of cybersecurity, and I don't want to go into all the details, that there are RTCA and other processes out there, but I just wanted to show that really cybersecurity and system safety, a lot of parallels. I took this diagram out of RTCA DO 326. It shows the system safety process, the classical functional hazard assessment, system safety assessment, etc. It put in security risk assessment, which is really the aircraft cybersecurity, the safe flight and landing bit, and I added the blue, which is really the process for mission assurance. So again, I'm just trying to point out that, you know, you can sort of map this out, and there's other interesting parallels. You know, we talk about security assurance level, SAL, you know, which is rather similar to design assurance level, DAO, and it sort of again lines up with how good your security measure is. You need a better security measure depending on the criticality of the failure. So I think that's all I wanted to say about that. Again, there's much more to say, but many other aspects of that. So I'm going to pass it back to our guest speaker, Major Roy. You want to take it from here?
Absolutely. Thank you. Next slide, please. So we're going to touch on the mission management aspect of this project and to highlight the capability gap that we had with previous legacy aircraft and how we will address those with this project. This is not the only component that we will be addressing integration gap, but it's certainly the one that's worth talking about today. So we decided to pick on this one too. To explain some of those gaps, I need to go back in history and give a bit of background. So as far as tech aviation goes, which is probably in the 1970s, intelligence, surveillance, and reconnaissance, ISR, that we sometimes just refer to as reconnaissance, has been one of the three pillars of tactical aviation. So one of the three main mission sets. Obviously, before in the 1970s and 80s and 90s, we had limited equipment to do so. So we were essentially using human eyeball, sometimes binoculars, and it forces us to be much closer to the enemy that we would like to be, obviously. But then in the 2000, with the new technology, we started seeing a lot more of EO/IR turret being installed on helicopters, and that became very important when Operation Afghanistan stood up. It was for a type of mission that we were doing overseas in Afghanistan. We needed those tools. So that's where the Ingress project was initiated and fielded this EO/IR sensor capability that you see on the left-hand side of the helicopter on the center of that picture, and also a moving map capability on a standalone brick that looks like the one that you see on the top right corner here. So because that project had to field this capability in a record time, there was very limited time to properly integrate it to the cockpit. So it was bought as a in limited quantity. So only a few aircraft were able to get that kit installed with very limited integration with our mission planning tools and limited connection also with the onboard military GPS or flight management system. This all resulted essentially in the increased workload for the aircrew. And we have a video that we'll show now to demonstrate that increased workload. And I'll try to comment on top of it. Chris, if you could launch the video now, please. So this is a video taken in Afghanistan from me. As a matter of fact, I had a helmet-mounted camera, and you can see how much my head will be moving on that 2-minute video. So at the moment, the right seat pilot is the one at the control, and honestly is the one that does a good job right now, only focusing on controlling the helicopter. But he lacks some display for the route and the mission map for his situational awareness. So he relies on me, the pilot monitoring, to give him those directions. And me on the left side, as you can see, my head keeps moving from down on the pedestal for managing my radio. I also have on my left end the MX-15 end controller that I try to operate the sensor with. And I also need to perform my pilot monitoring duties, so looking outside, forward and left to make sure that we avoid enemies or any man-made features or obstacles. I'm trying also to, right now you see me sometimes use the small moving map that I talked about before, because I'm trying to update the dynamic map based on inputs that I receive over the radios or from my back crew members about, hey, there's an enemy there, or there's a position here that we need to plot on the map to give back the reconnaissance. So I'm trying to do that, operate the ball, look down for the moving map, trying to give directions to the flight plan or where to go next, and try to communicate to external agency, whether they are my center of operation or ground unit, all this at the same time. So because of the lack of integration, I need to, the pilot flying rely on me to give him those directions, and I need to fight the system and constantly look down, losing a bit of situational awareness and not doing my obstacle clearance duty per se. So a customized interface on a moving map would allow me to be more efficient with reducing the number of clicks, having better controls to operate that moving map. Right now, the controls are a bit archaic, and also having a system that is located higher in the cockpit, so that my eyes don't have to travel that much up and down and be disoriented. So this is so we can resume the close the video and resume the slide. So essentially, GLLE will replace the Ingress mission kit, which was limited in quantity, with the full mission management system that will reduce pilot workload tremendously, and hence situational awareness for both the pilot monitoring and the pilot flying, and also increase the availability of the kit by making it a basic kit system, not just a mission kit. Mr. Drouin will now cover the technical aspect of the mission management on the next slide, please.
Thank you, Francois. I remember seeing that video from the first meeting I went to Gatineau, and Major Roy was there to present it with other people, and this was like eye-opening. So, you know, realized how much work there is even for the pilot non-flying. But here on this slide, you can see a summary of how this mission system is going to be done. To the left, you can see what's the mission kit. So essentially, it's the MX-15 and what goes with that equipment. But to the right, you can see what's going to be on the basic aircraft, which is essentially the moving map system or the mission system aspect of it. So Chris, if you can go to the next slide, we'll see little bubbles popping up. Major Watt touched on a lot of those points, but I'll go through that. So one thing he said is, you know, the GPS is going to be from the aircraft. On the legacy system, it was inside the MX-15, so and that had, you know, there was a GPS in the aircraft and a different one in the MX-15. It's going to be the same. It's going to be connected to the aircraft GPS system. The moving map is going to be available on all aircraft. That central display that you saw there, you probably remember seeing it at the right center of the cockpit. Those maps also and those videos will also be able to show them on those multifunction displays, you know, those 4 displays in the cockpit, so you can use different combinations of map and video in there. You also have connectivity between the mission management system and the FMCDU, which is also the flight management system. So the pilots will be able to transfer information from the FMS to the mission system to show a route, to show information, to show some points, and vice versa. They will be able to modify routes on the MMS, tactical routes only, of course, and send those back to the FMCDU, and then navigate to those. They're going to have a single data load for both the MMS and FMCDU, so that means that the ground system that they use, they will be able to prepare those and get the information for the FMS and for the MMS at the same time. There will be control will be at the MMS will be improved a lot by using a combination of touchscreen bezel buttons on the display and also some control panels in the pedestal. And one of them has a dial button so you can move the cursor, and has shortcut buttons so you can access, you know, frequently used functions directly from the pedestal. There will be an MX-15, so that's the rewire sensor interface within the MMS. The hand control is going to stay because it has, you know, a lot of stuff that they can do, and the pilots are used to work with it. But there's going to be an MX-15 interface also in the MMS, and the user interface will be 100% customized. So there's a lot of development that's being done there, but it's going to be highly customized, such that, you know, the functions that the pilots of the RCAF use often will be, you know, easy to access, and it's being designed by a team at CMC and very close coordination with the end user, which Major Roy is one of the representatives. So that's going to be the MMS. So lots of improvement, reduction in workload for the pilots for sure, and increased capability. So, and with that, I pass it on to François again, Major Roy.
Thank you, Pierre. So what does this all mean to the RCF? Not just the MMS, but the entire project. So it means a lot. So for us, it means that the project will allow the Griffin to be life extended up until and fly up until at least the mid-2030s in the configuration that is operationally relevant and interoperable with our NATO allies. This aircraft has been deployed overseas and used domestically over and over the last 25 years, and we expect it to continue to do so and remain a relevant asset for the Government of Canada and the RCAF. For the technicians working on the aircraft, this aircraft will be much easier to maintain, which will increase the fleet availability, and in time makes more aircraft serviceable on the flight line, which will allow us to conduct more missions. For the aircrew, and I'm talking about the pilot, the flight engineers, and the mission specialists, the CH146 Charlie Griffon Mark II will be safer to fly, operationally more capable, and also more compliant with civilian and military air regulation, making the RSF a better partner for sharing the battle space or the domestic airspace, airspace. So we expect a lot from this project. We are very enthusiastic about it, and we are looking very much forward for the first flight and when we start introducing it. So for the final takeaways and remarks, back to Mr. Falardeau on the next slide, please.
So so that's the last slide. That's pretty good. I think we made the good timing on this. So thanks very much, Major Roy. This was really exciting to have you part of this brief. I'll tell you that. To Pierre and Andy as well, the people that I work with every day. It's quite the adventure. So I want to talk about the little something that I think is a little special on this project is that this contract is based on an integrated product team approach that I believe is the truest integrated product team approach, which actually integrates completely the customer, the person who pays, the person who gives a contract, the client, that's the person who operates the end product, and the contractor. So working hand in hand from the beginning to the very end. They're PRMs every month. We meet and talk about the program at the highest level, and then we have at least 6 or 7 different working groups where the user, the customer, and the contractor get together in order to move the project forward and make decisions. So when the decision is made, it's a good decision, and we know it's actually from the user and from the customer. And rarely do we have to go back, and we never hear someone say, "Well, no, I didn't make that decision. Who made that decision?" So that's a very the bottom part on the that you see the relation chapter that is in the contract, in fact, and it's quite exciting to read that. Parties commit to acting at all times in a manner that is consistent with the following principle: do no harms, no secret, no surprises, no blame. So that no blame and no surprises is something that is quite novel with government kind of contracts. Which is very much welcomed by the contractor, because we don't need to know everything and then solidify that in our statement of work in a proposal and then get blamed when there's like new concepts or new scope that come up from the user. So the takeaway on the right is really our motto for the project is build a high degree of trust, leverage our existing tools, focus on efficiency, eliminate surprises, and have the best team. And that's it. I'll pass it over to Itzit now. I think we got good 10 minutes for questions. Before we go there, Itzit, do we have time for a video?
Yes, I give it to you.
Okay, so thank you very much. This was like in case we had time. So this is a time lapse of the first aircraft that arrived in February, and it shows how it went through a transformation. It's about a minute, so it shouldn't be too long. So go ahead, Tris. And that's it. Now it's stripped naked. Now it's up to us to rebuild it.
Wow, that was fantastic till the end. Extremely interactive. We can tell you have a really passionate team. Thank you very much, gents. And Major Roy, that was really, I love it. Thank you. We have now time for a question. We actually have 7 minutes. That's pretty good. You did a good job, guys. A lot of material in such a short term. Very interactive videos. Great. I'm impressed. Thanks. So the first question, I have a really good question from Michel Legault. Bonjour, Michel. Nice to have you on the line. We know you, Michel. The question is pretty technical. What happens to the HUMS, HUMS?
Okay, so I'll let Pierre go ahead on that one.
Well, we went into a competition for that, and we selected a new supplier. So we're changing the HUMS system on the aircraft. And this was a big decision. A lot of stuff went into this because some of you might know, but the Griffin support team has a lot of ground tools to analyze the data and get information from, there's a whole lot of people working on the ASIC side of things. So there was a big decision to go to a new system. But the intent is to keep most of those ground tools, if not all, just integrate the data with that, and we have this new system, and it's been selected. I think I'm allowed to say who we chose for this one, right? But we chose the Honeywell system, which is something that we have on our 412 line also.
Good. Thank you. The next question is from Christian Lemay. Can you talk about planned changes on the ASC equipment, the LRWS or the MAWS?
I'll try that one. There currently there was the ACE system. There's 3 components to it. They are being upgraded individually through our legacy project. So not part of GLE. Basically, will be upgraded. One has already gone through an upgrade, the RLWR. The other, the CMDS, is going to go through an upgrade as well, and it's right in the middle of that project. And in terms of the third one, which is the missile approach warner, that one will remain as is, I think, with the software change only. The nice thing about the ACE equipment is that the GLE project has a mandate to integrate the ACE equipment, meaning having them talk to each other to be more operationally effective. So, Major White, you want to complete that, or?
You covered it all essentially. So we have a few projects right now to update the system individually, and the digitalization of GLE will allow us to better communicate and be more effective. But otherwise, we have no plan to change the equipment individually in the medium term.
Good. Thank you. Christian says thank you. Next one, we see the interest from Michel Legault again. The question is for Major Roy. Can you tell us a little bit about the training that will be conducted?
So for sure, there's going to be initial CADI training provided by BTCL in Mirabel, but obviously that will be more focused on how to fly that new aircraft. But we internally ab initio training, we will have to refresh our lesson plans, to even create some conversion course and fully update our initial training course to incorporate all the new system. A big part of it has to do with automation for us. So GLE will enable a 4th-ax autopilot, which will require us to change some of the ways that we've been using the aircraft. A lot of our older pilots still fly the aircraft without autopilot or without automation, and we got to be better and follow the civilian trends for this. The same with all the PBM. So this aircraft right now is not very PBN capable. So there's a lot of new IFR and domestic concept that we will have to introduce based on the certified new civilian GPS that we'll put in. So there's going to be an effort, but we are already starting working on that. We have special working group that are starting to shape, structure those courses, and we expect that's going to be a transition, 1 to 2, 3 years transition to convert all our crew in a very safe and effective manner.
Hey, well, thanks. And maybe we have 2 minutes left, just enough for the last question that I think is really interesting from Stéphane Roy. I don't know if there's a link between you, Major. For the mission, did you run proof of concept via simulation for human factor configuration and mission success? Maybe that's for Pierre.
No.
Well, okay, so it's a loaded question, so I'll try to answer best. But for the mission system, pedestal layout, cockpit layout, human factors were involved. Specialists were involved right at the beginning, and even a lot of that was done through the pandemic. But we were able to do mock-ups. You saw one which is a cardboard, so that was more the physical aspect of the thing. But then when we talk about user interface, customized user interface for the mission system, we have the human factors people in the room when we have discussions. We have the end user also in the room, so Major Roy participates in those discussions with other pilots often, and we have discussions about all those little details that make up the human factors, stuff, and that make up the pilot workload go down when you use those systems. So the human factors are very, very much involved in physical layout of the cockpit, and also the user interface for the mission system, but also for the other system, which is the FMCDU, which is the FMS and AMS on this aircraft. Anything to add, Major Roy?
Maybe I could just add that we like to consider ourselves like an educated customer. Maybe that's an overstatement, but we have some history in that. So we've been operating that aircraft for 25 years. Lots of deployment where we exchange with foreign partners, colleagues. So we kind of knew what we wanted to start with. We usually document our lesson learned and our capability gaps. We have a process for that. So contrary to a new fleet like the CC295, for example, or the Cyclone or the Chinook, we had a ground starting point, and we kind of knew where we wanted to be, and then getting some HFE, human factor engineers, experts on board. It was we were allowed to communicate that properly, so that Pierre and his team could do something with it more than just the feeling feedback, emotional loaded feedback that you would receive from pilots. So we put that right bridge in the middle. That's it.
All right. So thank you very much, Major, and everyone. I think we're past the hour. We're at the hour right now. So unfortunately, I'll have to stop the questions. So thank you very much, everyone. Hope you enjoyed, and we'll see you at the next VFS presentation. Have a good day.